Good morning, everyone, and we are here to begin this morning with the Leading Edge Forum. The topic this morning is automation in the paving industry. This was one of my favorite sessions when I first started in AAPT in around 1993, I think. Gene had welcomed me. Jim Schrockman had given me his opinion. And at that time, one of the forums that I remember so often was the Government Engineers Forum on Sunday afternoon. And in that forum, as a former government engineer, as I used to work for Kentucky Transportation Cabinet, I remember we would sit around at the table and everybody else had to take a seat behind us and weren't allowed to really speak as the government engineers would go around and talk about current issues of the day. That was such an attraction back then, but as you know today, it's really hard for our government engineers to make it to meetings such as this. Today, and I think it was Tom Harmon who may have led the way with this with the board and others, to change it to the Leading Edge Forum, which was typically on a Sunday afternoon, and we have now moved it. This is the first year we have moved it to the session that we have now. As our starting session for AAPT. While it's not the Government Engineers Forum anymore, it is one that we want to keep somewhat practical in this regard, as several of us had talked about over a few phone calls, and I appreciate those who helped put this together, whether by email or through those phone calls. We came up with two topics that we thought would be very good to start off with. I also want to say at this time, this session is being live streamed. If you didn't know this, Randy West has become quite the YouTuber in the past day. And Randy's back there working that along with Dave. And Dave, thank you for running the cameras. I know you like to look at stars, but thank you for pointing the cameras today. And this has been, and as it's streamed, it's also being recorded. So this session will be available for playback in the future. Always want to say that anything that's said, and especially for the stream, is that the opinions that you may hear today is not necessarily the opinions of AAPT or the board, but of those who are presenting. With that, I want to introduce our first speaker and the topics that we'll have today. The first speaker that we have is Likram Narsing, and he said just call him Nars, as most folks are used to calling him. And he has come in today, and we really appreciate you being here. We know it was a little bit of a travel for you like the rest of us, and welcome you down to the sunny and warm state, or almost warm state, of Fort Worth, Texas. The topic that he'll be speaking on is 3D paving and advances and limitations. This was a topic that we found really interesting, as I didn't know much about it, and as we began learning more, we thought it would be a good one to start off with this morning. Nars comes to us again from Vogely, but before that he was with Ingersoll Rand. Started in 1990 in the paving industry as a project engineer, had held several positions since then, and then today is the project manager for Vogely. With that, let's all give a warm Texas welcome to Nars.
Thank you very much, and thanks for having me in cold Texas. So today our topic is 3D paving, advance, and limitations. This is not a new topic. This topic's been around for a while now. In 2014, FHWA grouped a number of guys to put together a webinar for 3D paving, what they call asphalt stringless paving. So as you notice, there's a group of people from different organizations, because to do 3D paving, you need at least two groups of knowledge. You need equipment knowledge and you need 3D positioning knowledge. So you can't find one group of people that is very knowledgeable in all aspects of 3D paving. All right, Phil. Seems like we're changing a bit slow. You also notice that FHWA with their SHARP 2 program has been pushing what we refer to as intelligent construction technologies. One of the intelligent construction technologies is 3D paving and milling. So again, these are topics that are evolving and being pushed heavily by FHWA. All of this got started with intelligent machine controls. Intelligent machine control started with the introduction of the Tier 3 emission control engines. At that point, we needed a computer on board to manage the emissions of the engine. So with a computer on board, now we have the opportunity to do a whole lot more with the paving process compared to before. Let's do a quick review of what an asphalt paver is and a free-floating screed. An asphalt paver consists of a tractor and a screed. There are several types of screeds, but as far as 3D paving is concerned, it does not matter. The tractor is attached to the screed arm where it pulls the screed at what we call the toe point or pull point. The tractor is connected to the screed through the leveling arm, which is connected to the screed arm. The screed itself is pivot on each side onto the screed arm. There's a screw that we refer to as a thickness control screw. That the operator could manually increase or decrease the mat depth. So if the operator turns that screw, he will momentarily increase what we refer to as the equilibrium angle of attack. The operator could also leave the screw alone and he can jog what we refer to as a toe point cylinder. So when the operator turns the screw, he's increasing or decreasing that angle of attack. He could achieve the same by running that toe point cylinder up and down. If you notice, the toe point cylinder is connected to the leveling arm, which is connected to the screed arm. So if I run that up, I could increase that angle. If I run it down, I could decrease the angle. So that's two ways the operator could increase or decrease the mat depth. We could also use an automatic grade and slope system to follow a known reference to accomplish the same. That reference could be a physical reference or it could be 3D coordinates. The screed is held to grade by 5 forces. Any change in those 5 forces would also cause a change in the mat depth. So we could manually change the mat depth, we could automatically change the mat depth, or the mat depth could change unknowing to us if any of those 5 forces changes. So we could increase the mat depth manually using a thickness control screw or using the toe point, or we can automatically increase or decrease the mat depth with an automatic grade and slope system. Whenever we made those changes, it takes 3 to 5 times the length of the toe arm for the screed to find its new equilibrium position. So the screed is like a water skier being pulled by a boat. When you make a change, it takes time for it to find those 5 forces back in balance to seek the new grade. So I could increase my mat depth by turning the screw or by using the toe point cylinders. So if we use automatic grade and slope system to control the mat depth, we could either use a physical reference or we can use 3D coordinates. As the tractor goes in and out of the highs and lows, As the tractor goes in and out of the highs and lows, if we have a known reference, assuming that front wheels goes into that dip, the toe point cylinder will go down. When we say that if the toe point goes down, we change mat depth. But we also say it takes 3 to 5 times the length of the toe arm for the screed to reach its new equilibrium point. So that being a short variation in the mat depth does not give the screed enough time to react, so it would fill that mat depth. When we get into the longer swales now the screed could react and carry the depth in. If we use an automatic grade and slope system, we can follow a known reference and compensate for those variations in the base, whilst at the same time compensate for variation in changes of the 5 forces that holds the screed to grade. So using an automatic grade and slope system, we could follow a physical reference or we can follow a 3D coordinate. As you can see here, that's a physical reference. We're matching a joint. And these are your 3 coordinates of the pavement. You've got Z, which is the depth, X, which is the width, and Y, which is the direction of the pavement. Those are your three typical coordinates. So, following a physical reference, using an automatic grade and slope system, we need three things. We need the physical reference, we need a sensor to monitor the reference, and we need a machine control. So the sensor monitors the reference and tells the machine control what to do. And it's really easy. It's up or down, left, up or down, right. So we can control depth, or we can control all three dimensions of the pavement. So first we'll look at controlling depth only, which is what we do mostly today. It's controlling depth. On rare occasions, we control all three dimensions of the pavement automatically. So reference and sensors are usually a joint, a string line, a curb, or we can use an averaging ski and average the base. Sensors could be the sensor that reads the joint, which we refer to as a joint matcher. Or we read the slope of the pavement with a slope sensor mounted on a beam that attached to the two arms that controls the mat depth. So when we're using physical reference, it's usually a joint sensor or a slope sensor, or a joint sensor and a slope sensor. We can run joint on one side and slope on the other side. So we control the depth on one side of the pavement, and we hold a cross slope of the pavement. Machine controls could be integrated controls to the paver control, or it could be a third-party system, and you'll hear these names over and over in my presentation, Topcon, Leica, or Trimble, which are the three big players in positioning instruments. Machine control are usually on the paver. So we could have an integrated control system where the sensor talks to the integrated control to control your grade. Or we can have a third-party system to tell the machine what to do. These are some typical integrated machine controls, which we refer to as intelligent machine controls. You can see all kinds of digital displays, and so it gives the operator the ability to do a whole lot more. At the bottom of the control is all your screed functions and your material delivery functions. So built into the control is your automatic grade and slope controls. These are some typical third-party controls. When you use a third-party control, usually you have more wiring, more junction box, more trip points, and of course, more probability for problems. When you have an integrated control, it simplifies the circuit and accomplishes the same thing. So that's following physical reference. Why 3D? 3D eliminate the need for physical reference. Physical reference sometimes could be very expensive, especially if it's a new project and you have no reference to go off. So 3D system eliminates the need for physical reference. It's usually safer because you have left strip points. And you can use the same 3D position instruments for all the dirt work. So you notice I'm focusing on 3D positioning instruments, and 3D and machine controls. So if we're paving, controlling depth with 3D, we could eliminate the need for expensive string line. As you can see here, that's a brand new project. There's no reference to go off. Where would the operator steer off? To maximize smoothness, maximize your joint, to have proper joint, you have to steer a straight line. To steer a straight line, the operator needs a reference. So if it's a new project, you have to survey it and put survey stakes down for the operator to follow. We can use the same string line as a reference to control the grade. That could get very expensive. If it's a new project, the file's already designed, it's already available, we can take that information and plug it back into the paver and let the paver follow that reference. These are some typical applications where 3D becomes very handy. As you can see here, that's a very complicated or complex profile of the pavement. So if we could steer the paver with the 3D job file, it make it a whole lot easier for the operator to maintain consistency of those 5 forces. So we have a better product at the end. It also eliminates the need for the manual input of the operator to follow that complex pavement. So 3D also eliminate the manual input. We could also do 3D mill. If we do 3D mill, then we already establish a smooth base that the free-floating screed could follow. So if the base is smooth, and we can always profile it and tell how smooth the base is, so more than likely, if you do 3D mill, you don't have to do 3D pave because we already established a smooth base. So to do 3D paving, these are the things we need. We need 3D job files. We need 3D positioning instruments to tell the paver where it's at and what's the depth needs to be, what's the width of the pavement needs to be, what the direction the paver needs to go. And then we need machine controls to take that information and control the machine. So 3 things we need is 3D files, 3D positioning instruments, and machine control. The 3D files could be for new project, the design file, or for existing project, existing pavement, we can scan the pavement either with a high-speed scanner or we can survey it. Then we can take that information and build a 3D file. Then take that and feed it back into the paver and let the paver control the depth of the pavement based on the information we input into it. So let's say we have an existing base that's got highs and lows. When we scan that surface, we can find the low spot, we can add X amount of material for roll down. So when the paver comes by, it put X amount of material to compensate for the low spot, so when the roller comes by, we have a smoother pavement. These are latest technology, these are evolving technologies. This type of technology could eliminate the need for, in some case, we have to do a leveling course to create a smooth base before we do the final pavement. So these are some of the advantages of this type of technology. There are 2 types of 3D positioning instruments. There is what we call UTS, Universal Total Station, or millimeter GPS. They're from different suppliers. So UTS uses a universal total station, and a millimeter GPS uses satellite and GPS for location, for X and Ys. UTS has to use multiple stations so you can pick up from one to the other and not lose control. You would need at least 3 total stations if you use the UTS technology. 1 for tracking, 1 for transition from one to the other, and of course, we always need to constantly check grade because remember, input equals to output. So we have to constantly check our grade. So we need another total station for grade checking. These are some of the typical instruments that are used for 3D positioning or 3D paving. So we have the total station. We need control points for the total station to work off. The total station communicates with the machine target to tell the machine where it's at. All these instruments are communicating with each other through a radio signal, so we need that. Then we have the 3D control box, which takes the 3D file and tells the paver what to do. Well, it talks to the machine control. Of course, we need to sense the mass. If we're going in and out of super elevation, we need to calculate when the mass is tilting so we can recalculate the X and Y. We also need slope sensor that will tell us what the cross slope of the pavement is. And we, of course, we need a rover to constantly check the mat depth to make sure that we're getting what we expect. So that's some of the stuff that is used when we use the universal total station system. The millimeter GPS, of course, we need satellite to tell us where we're at. Usually, millimeter GPS is not accurate enough for the accuracy that we're looking for depth. So whenever you use a millimeter GPS, we use a laser to give us the mat depth. So millimeter GPS position the paver, laser tells us what the depth is. With this concept, you have, of course, the GPS system, GPS and laser system. Again, you have a 3D control box. And of course, we also need a rover to constantly check our mat depth. Pros and cons for these systems. Usually, when you use the UTS system, you need, of course, multiple stations. And you have to be careful that you don't have blockage with your total station. If a truck goes by or you get in, a wall gets in front of you, you block your signal and then you lose your position. So that's typically one of the disadvantages, and also multiple stations. You can have obstructions like walls, overpasses, bridges, trees, those types of stuff that block your signal, and you lose your X and Y position. To determine what's best for your project, there are several things you need to look into. And you can see some of them there. I'm not going to go through it line by line, but of course, if you choose to get into a project like these, you need to investigate your project, look at the pros and cons of the UTS system and the millimeter GPS, and then determine which is more appropriate for your project. We always have to constantly check mat depth because we know input equals to output. If your file's incorrect, it tells the paver what to do, the paver will do it. So we got to be very careful that we have knowledgeable people available when you use these types of projects. Remember, I said there's two groups of knowledge. There's machine control knowledge, and there is 3D positioning knowledge. 3D positioning knowledge also includes creating a 3D file. So you need to have surveying knowledge, you need to have positioning instrument knowledge, and of course you need to have machine knowledge, which includes paving knowledge. And that's usually difficult to find. What we find mostly on projects is the 3D positioning guys gets involved, they sell the contractor the package, they start it up, and they walk away. Because the machine lays the pavement, most of the blames goes to the machine. So it's very critical to be able to, if possible, specify the knowledge required if you're getting into projects like these. The contractor must have the knowledge to be able to run these types of projects. Otherwise, you can quickly get into millions of dollars of lawsuits, which I've seen in the past. Paver OEMs are not experts in 3D positioning. The 3D positioning guys are. Machine controls, again, could be the same as the integrated machine control, or it could be a third-party machine control. If you use a third-party machine control, then you're getting into more complex wiring, more junction box, more trip points. As you can see here, these are three of the typical systems, and I use these three because this is what we get involved in mostly. There are others out there. But if you use a Trimble system, then you need a Trimble 3D positioning box, you need a 3D machine control, and you need discrete control. Likewise for Topcon or Leica. If you use an integrated machine control, then you avoid those additional instruments and additional wiring and junction box. So controlling depth, width, and direction. So far we looked at controlling depth. We could also steer the paver, and we can also control the direction of the paver. So now we can take a 3D job file and we can do depth. Our industry today refer to depth alone as 2D paving. That's incorrect. 2D paving is controlling depth and controlling width. That's two-dimension. What we refer to, our industry refer to as 2D paving, is following a physical reference. Following a 3D job file, you can control the depth, you can control the width, and you can control the steering based on the file. So again, we need 3D positioning instruments and we need machine control. But now that we're controlling all three dimensions, we need additional sensors on the paver. We need a sensor to tell us the width of the screed. And of course, we need sensors to tell us the direction that the paver needs to go. So all of that now belongs to the machine control. So again, two groups of knowledge, machine and 3D positioning. So that's my 20 minutes. we left some time for questions. Yeah.
Hello, Sebastian Bukowski, Creighton Polymers. Very interesting presentation. One question, you mentioned a lot about the 3D design before the project. Could you explain a little bit what it entails for people who don't understand it very well, such as myself?
Okay. So if we take a new highway, for instance, we start with a rough terrain. We have to grade it, or we have to dose it, and then more than likely we have to grade it. Then we have to lay a gravel base, and then we have to lay the final pavement. We're not in the 3D design business, but I could tell you they will start with a horizontal plane and then work their way from bottom up and create a 3D file with that. So you take that information, when it comes to the paving, you take that horizontal plane and you work from there down to build your mat depth. Hope that answers it. Okay?
John D'Angelo, consultant, very interesting. One thing, though, I wanted to ask you about, you showed a slide where one of the things that you're looking at is compensating for the mat thickness to
Yes.
adjust for dips.
Right.
And the one concern I have with that is that assumes that you're going to then get extra compaction in that area with the roller.
Yes.
And right now, most of the things I've seen, we don't have that. So in that case, you'd actually end up with a hump, or you poor compaction in that area. So I want you to...
Very, very good concern. It's a very good concern. And all the players in that technology have done enough studies and set their program up that if you know your mix design, you know what your roll down is, then in your equation, they compensate for the roll down based on the mix design. And they compensate for the behavior of the free-floating screed as you approach the low spot. It gives it enough time for it to start increasing the mat depth. So it's all in the programming. That's a good point.
Gail Page, consultant. I guess the same concern that I had. As you said, it takes 3 to 5 lengths of the toe in order to compensate for the depth that you really want. It would seem to me that the current method of using some physical or straight edge or whatever seems to not be able to compensate for the depth as well as it should. And the 3D or a depth digital file, if in fact they put the inputs in so that you can get the right depth at the right location, would in fact improve the overall smoothness of the pavement.
Right. There is, what I didn't show because I didn't have time to cover it all, what I didn't show is in that process, they have three different processes. They have a software to mill it so you get closer to a smooth surface. Then they have a software to pave it based on whatever dip is left, and another software for the roller to put extra compaction at that point. So it's all the points are very relative points, very good points, and this is where the OEMs that are making these systems have to be very focused to ensure the final product is smooth.
Irv Ducat, Matthew Construction Company. Very interesting presentation. And I just want to underscore a point that you made about the 3D design files.
Yeah.
Especially as the UTS system, is that for the length of the project, you have to have a uniform database.
Yes.
And this goes back to using these controls, and if there's no internal control to make sure that the files match up, you end up with a situation that's often characterized as a bridge being built and the alignment is going off into the space when it tries meeting at the end of the river. And for projects where DOTs are using the 3D controls on a project, we find it's very often that as you cross county lines, you have a different GPS system.
That's right.
And without checking, you can get nasty telephone calls that asking why the paver's not where it's supposed to be.
Exactly. Another very good point, and you notice how many times I repeat myself that we have to check. Input equals to output. You don't want to check after you finish half a mile. So these are all things that we have to be focused on when we're using 3D paving. Any other questions? All right, well, thank you guys very much.
Nars, we really appreciate you coming to join us and sharing that. When we talked about that topic, I hadn't heard about it, and I mentioned it to the board, and a few of the folks on the board said, "What is 3D paving?" So we thought that would be a good topic to share. I want to show a video here in just a moment of a 3D paving project, one that's a little closer to my heart, and then we'll have Stacy, and we'll get out a little bit early for lunch. I don't think anybody will argue for that. Share a story or two with you. My first AAPT meeting, I had worked under Jerry Huber on the SHARP program and this little thing with the InDesign development, and I was really proud of that, Jerry, and I was excited and came to my first AAPT meeting, and a guy named Dwight Walker introduced me from Kentucky Transportation Cabinet, and he brought me into the Government Engineers Forum that day, and he started introducing me, and I began to see a face or two I knew, and that was the day I'd met Gene, and Bob McGinnis I knew, and Mike Anderson I knew, but that was about it. And they introduced me to this fella called Jim Schrockman. And Jim said, "Well, welcome." And at that time, Jim, you had a beautiful lady on your arm, June, who was with you at that time, and Jim said, "So what'd you do?" I said, very proudly, I said, "I worked for the Transportation Cabinet. I was at Asphalt Institute and helped invent the gyratory table for the InDesign gyrations." He said, "Well, you're the one to blame." I knew right then I was going to fit in well, Jim, and I figured you out pretty quickly, and that your bark was a lot worse than your bite. But I appreciated that Government Engineers Forum, and I always appreciated this leading edge piece, to where again we try to blend a lot of the technology, the up and coming technology, with that of what is real. I also remember that those first times when I would see these presentations, and I would get this pit in my stomach that I don't know what in the world they're talking about. I'm not smart enough to be here. Then I realized I'm like a lot of the other folks who are out there, and everybody has their specialties. And what we're all here for is not to make little of anything or make it light, or at the same time we don't have to understand it all, but have respect for what others are doing, and realize that a lot of the things that are presented this week will also be used in the future. If you would have told me back in the time when I was sitting there at that Government Engineers Forum that, we were looking and trying to understand what SuperPave was, and I remember the biggest question we had was, how would we blend SuperPave at the time that we were implementing quality control? Both were happening about the same time, and it was a lot for a lot of DOTs to take on. Texas DOT had implemented quality control, and I remember Kentucky was trying to follow. And now you have these agencies trying to implement quality control and SuperPave at the same time. And SuperPave had the binder specs, and we had the aggregate specs, and we had the mix design, and trying to phase those in, and how do you do that? And those were healthy discussions that we had. Not any different than what we're doing now as we continue to look at these newer pieces of technology that they throw at us. Some that we will find that become more commonplace, and others, maybe it's pie in the sky. But a lot of times that becomes that reality. My original name for this forum was Bleeding Edge Tech, and I thought that was just awesome. But the board informed me that we got to keep it a little more practical, and we came up with automation in the paving industry. But in the back of my mind, I still think about those advances that we can make. And so before I introduce our next speaker and we begin to talk about how we begin to blend these things in, what I want to do is show you a video of the 3D paving and why it was important. It wasn't just something for fun, but it was absolutely critical in the paving of the Corvette track in Bowling Green, Kentucky. Through the use of the 3D paving, you're going to see here with Mike Law from Scotty's, they're going to explain to you why the need and how they use this for the practicality. It's about 3 to 4 minutes.
At these speeds, there is no margin for error. That's why the surface at the new National Corvette Museum Motorsports Park in Bowling Green, Kentucky is among the smoothest ever placed.
Yeah, racing at speeds up to 180, 200 miles per hour, this thing better be smooth.
The NCM Motorsports Park will serve many purposes. It is a test track for Corvettes, with a Corvette museum and a General Motors factory less than a mile away. It also will be used for various types of driver training. Car, truck, and motorcycle clubs can rent the track as well. Achieving the required smoothness was the challenge. Technology that included 3D paving helped every inch of the way, from the first pass of the scraper during site preparation to the last roll of the finished compactor.
In this case, when we're doing the 3D paving, the contractor, Scotty's contracting, has come in and they've built models, 3D models, and we put those on the paving systems, on the particular Trimble system here, on the Caterpillar pavers. We've got a full 2D sonic system on it. And so we have 2 operators boxes that has that on it. And then we also have another operators box that's to run our PCS 900 system, which is our robotics paving system. And then we have multiple robots set up, and there'll be, in this case, they're running here what they call echelon. So they run 2 pavers, staggered session there to it. And then we'll have robots multiple robots that are tracking both pavers. And then as they get out of range of one paver or one robotic system, then the next robotic system picks them up. So you'll see out here as many as 6 robots set up at one time.
The technology ensured steps were taken throughout the process to deliver tolerances within thousandths of a foot.
The biggest advantage, I guess, for the 3D paving would be the accuracies we're needed to achieve for the Corvette racetrack here. And so we're able to hold those in the thousands.
The advanced technology delivered incredible smoothness results while also having a significant impact on cost.
Technology cuts our labor force down. We don't spend near as much. When we save money, that enables us to bid cheaper and to win bids. And our company prospers with those things.
Time pressures also were a part of the job, and once again it was technology to the rescue. In this case, the technology enabled work to begin before all plans were finalized.
The Corvette Museum wanted to start the project. They did not have it fully designed yet. The engineer was working extra hours, but it just wasn't quite ready yet. So we did somewhat of a phased construction, design build. With the changes, the way they came in, we were constantly updating the modeling parameters out to the machines. Those kind of changes are not feasible to come out and stake and do that the conventional methods.
Was the job a success? Corvette official Mitch Wright certainly thinks so.
They can hold tolerances to an extremely tight level. And what that's going to allow us to do and what it's going to provide us is a hyper smooth racetrack. And I believe we're going to be the envy of the industry with the surface that we're going to have.
Thank you to our AV guys for making that, getting that queued up and showing that video. One I thought would be of good interest, and just to let you know, a few good things come out of Kentucky besides Del Decker, myself, and Cami Armabu. By the way, Cami R, it's good to see you at AAPT this year, and good to have you here. With that, again, I want to encourage you as you begin to look at these technologies that you see. Think about how those will blend in the future, and it may not be in the exact form that you're seeing now, but it may be something a lot different. Where's Becky? I'm looking at Becky. Becky, you remember when we had the Super Pave level 1, 2, and 3, and that big SST and one that was sitting in your place, and we had them in all the different super pave centers. And we were trying to figure out how in the world this big machine that Jim Cox had designed was going to fit in these laboratories or in the DOTs, and who was going to run them. But that was a vision that we had back in '98, and today that vision is not that big unit. However, it's the smaller AMPT unit that's doing a very good job. So it may change in size and may change in how it works, but ultimately we're all moving the same direction. I'd like to invite the next speaker up, Stacy. And Stacy, thank you for your willingness to present this morning. Stacy is the Materials Technology Manager at Payne & Dolan. She is in charge of 3 AASHTO accredited design labs and all of the research and R&D there and the activities for Payne & Dolan. She's worked with binder and mixtures and performance testing and has a true passion for moving automation forward in our industry. Stacy, on your way up, I was going to also mention that Stacy championed recently an ASTM, helping us to get some new standards on this automation and working that through. And I think that one has passed, and you can even mention that standard while you're up here. I think that's good to share. Thank you, Stacy. Well, let's welcome Stacy.
Thanks, Phil, and thank you for this opportunity to present today. Like Phil mentioned, I have been in the industry for almost 20 years, and I have had the opportunity to work with many people who have pushed automation in this industry, and I think it's time to take it to the next level. When I started, Super Pave was new, but I didn't know anything else. I didn't know what Marshall was. Performance graded binders were new. Pen grading, I had to learn about backwards, and I have over time, and I've come to appreciate all the advances we've made in this industry. And probably every one of you here has had some input into different things where we've been able to advance as an industry and continue to move forward. And I think it's really time for the next big step. Automation is taking over in a lot of other industries, and in a lot of ways, we are pretty far behind. So today I want to take this opportunity to talk to you about innovation and automation, and I'm also going to go through challenges and opportunities that we might face. Automation is a key component of our industry moving forward, and we all have to embrace it in order to do that together. So, as I was putting together this presentation and trying to frame it in the context of AAPT and what AAPT means to me, I went out to their website. And some of you may have seen this recently, been out there registering for the meeting or looking up the annual meeting minutes. But it struck me, down at the bottom, AAPT is a leader in the advancement of asphalt paving technology. To me, that speaks volumes, and I am proud to be part of an organization that does that and has been doing that for multiple years. Getting all of us together in the same spot to discuss ideas and move things forward has been a key component of this industry surviving and thriving as long as we have. So I think this automation and innovation presentation fits right in with AAPT's focus. And I'm going to say it again. They've been a leader in the advancement of paving technology. So let's keep leading the way. This is just a quick reference of what I'm specifically going to go through today. So I'm going to talk about innovation and automation. What are they specifically? There's different definitions, especially innovation. Has been used in many contexts. It gets used out of context often. So I just want to define what it means to me before moving forward. I'm going to go through a lot of different types of testing: asphalt binder testing and sampling, aggregate sampling and testing, mixed sampling and testing, and also do some field paving automation. And then I'm going to finish up today with some challenges and opportunities that are available to us with the new automations that are available. Some of the things I'm going to talk about today are currently available. They're being used in labs. Some of them are concepts, things that are maybe being used in other industries but that we have not embraced yet. And some of them aren't even here yet. Some of them are just ideas that we can promote and move forward to make our industry better and faster. So what is innovation? Innovation, in its simplest form to me, is about staying relevant. If we're not moving forward and we're standing still, we will not stay relevant. We are not too big to fail. And we must understand that there are other companies that do paving and that can do what we do, and we must stay relevant by innovating. Innovation is about adapting to change. We've all heard stories about companies that didn't adapt, that didn't take on the next challenge. Names like Blockbuster come to mind immediately. We always have to be innovating and looking for the next big thing in order to stay relevant, and adapting is very important. One thing that often happens with innovation is that people want to focus on the solution. And one thing I really want to challenge all of you to do is focus on the question. What are we trying to do? How do we make good asphalt pavement? Focus on the question, and then find the solution. The solution may be available already, it may just be a concept, but strive to focus on the question. So an example of an innovation, and like I said, when I started in the asphalt industry, SuperPave was fairly new. Marshall hammers, I saw them in the lab. I couldn't even begin to tell you how to use them. And as I've learned over the years, Marshall hammers themselves were quite the innovation at the time. But as Sharp came about and had three main objectives. It was investigating why some pavements perform well. So that was the question. And they were supposed to develop tests and specifications that would outperform and outlast the pavements being constructed today. And then the third part was to work with highway agencies and industries to implement what they found. Based on my experience, I would say SuperPave has been highly successful. The roads we're paving today are supporting our current flow of traffic, and now we just need to do better. So, well, this was an excellent innovation at the time, and Sharp is an amazing program. We need to continue to move forward. I also want to point out that due to Sharp, there's been more than 100 new devices, tests, and specifications, and it also has brought about innovation through AASHTO, FHWA, and TRB. So this program had a lasting impact on our industry. Another example of innovation that came out of Sharp initially was G-star divided by sine delta. And while at the time this was a great innovation and allowed us to move forward with our PG binder specification, it did not account for what was coming next. And what was coming next was elastomeric binders. Heavier loads, slower traffic. G-star sine delta was not prepared to deal with that. So the development of Masker came about because grade bumping was not going to cut it. We could not test our binders at 70 degrees Celsius when we were actually in a climate that needed 58. So the development of Massacre was truly an innovative idea, and it's truly pushing us forward. And I hope it's pushing people to stop using PG plus specifications. GNR has better correlation with elasticity, and the Massacre test in general is more stress sensitive, so we can better predict which pavements will and will not rut. Another great innovative idea that has come about recently. The last example of innovation that I want to talk about is asphalt binder content. Asphalt binder content has been a key component of our agency specifications where I work for as long as I can remember. And there has been many iterations of trying to figure out how to get the asphalt content. So reflux is a test. In fact, we still run it in one of our states. It requires over 24 hours to get an answer. It requires a technician to be very hands-on and takes a lot of time to run. It's very accurate. It gets you the right number, but it's very labor intensive. It was also very ripe for automation. And one of the automations that happened was centrifuge. So now we can run it faster. It takes less technician time, and it's also still very accurate. So there is one area that we're still developing. Ignition ovens are now a thing that we're using, which somewhat eliminates our need for chemicals, which is a safety issue. However, when we use ignition ovens, we still need to use chemicals to determine correction factors. So there's still innovations coming today in this area, and it's one area we'll talk about later. Next thing I want to talk about is what specifically is automation. And automation is just typically refers to something that it exists and functions as an independent process. We have been using automation to make our lives simpler for years. It works because most people don't like repeating the same task over and over again. They'd rather be doing something else. We can never get enough, as some people like to say. So as much as people might be concerned about job elimination, there will always be something else that we want. Just because we automate does not mean we will stop innovating, and those innovations will result in other things we want to do, like yoga or Pokemon Go. We're always going to find something to fill our time. Automation will give us that ability. Excuse me. So, I don't know if anybody in here is currently auto-sampling their asphalt binder at their asphalt terminals. One of the processes that I am familiar with right now is that we have the truck driver determine when the truck is halfway loaded. We hope he clears the line, and then we have him take a sample. And we set that sample aside, and we hope that if there's a problem, it's right. I know from experience, and my colleague Carlton can speak to it as well, it is not always right. We may not have trained that truck driver properly. He may not have cleared the line. We have the ability to integrate with our loading system so that the line clears itself, it pulls the sample at exactly halfway through the load, and we get a consistent, accurate sample every time. With everything that's riding on our asphalt binder being correct, and remove and replace a possibility if the sample was not taken correctly, this should be a no-brainer at asphalt terminals. We should be automatically pulling these samples rather than relying on humans to do it for us. And I don't think the truck drivers would be too upset about that not being their responsibility anymore. This is something that is being used in other industries, and if any of you are using it in the asphalt industry, I'd be really excited to hear about it and talk to you. This is an automated asphalt binder testing rheometer. It's the only one that I know of, so I'm not promoting the brand. It's just the only one that I'm aware of at this time. Hopefully there's more coming out on the market. This machine will take your samples and run your DSRs and run your massacres without any human intervention. You can preload the samples, have it all set up, and it will run all night long. You can also integrate it with the asphalt binder sampling that I just showed you previously. You could pull a truck sample, have it hooked up to this piece of instrumentation, run the sample, and have the results automatically reported every time a truck is loaded. You could literally have the data before the truck leaves the site. I have been on the other end of the truck leaving the terminal, and the material's been placed, and then I get the data, and it failed. It is not a great feeling. It is not a great feeling to know I was responsible for that material, and our company put it down because I told them it was okay, and it wasn't. This could actually eliminate that truck ever leaving the site. How great would that be? I talked a little bit about advances in asphalt binder content. So automated extraction and recovery of asphalt binder. This is what Phil was talking about. we helped push through an ASTM specification to get this instrument and other ones like it onto the market with an ASTM approved specification. It was a challenge, to say the least, to get it through, but we prevailed. And this next generation, which I'm not even sure is on the market yet, it actually takes it to the next level. So this particular instrument, for those that aren't familiar with it, is basically a washing machine. It removes the asphalt binder from the aggregate. It pulls out the P200 and runs it through a centrifuge and leaves you with dried aggregates that you take out, dump through your sieve set, and weigh. It reduces the time of extraction and asphalt binder content and aggregate gradation to about an hour of a technician's time. When I figured out the payback on this, it was well less than 3 years. So all this equipment and all this automation is not cheap. Figuring out your ROIs, your return on investments, is a key component of making sure we're making good business decisions. In this latest update to the system, and now it includes rotovap recovery. So you can take the sample of aggregate, hot mix asphalt, put it in here, get your dried aggregates out, and now you can also have it automatically recover your asphalt for you. This is huge. These kind of innovations are what we need in our industry. Here are some examples of some automated aggregate sampling and testing. The one on the left, or I guess your right, is on an actual aggregate line. So it's pulling the sample off of the aggregate belt, dropping it through a system that's drying the aggregate, so you're getting moisture content, and grading it, putting it through the sieves, and you're getting automated moisture and gradation data out of this system. The one on your left is in a lab setting, so the sample was taken by a person, and the same thing is being done. It's automatically getting your moisture and your gradation without human intervention. This type of technology is available today, and yet we still have technicians running these tests when they could be spending their time doing other activities, more complicated tests. This is an automated aggregate testing lab. In this lab, the sample gets queued up and a robot does all of the aggregate testing. No human intervention. We're doing moisture, gradation, specific gravity. All of our typical aggregate tests are automated, and we have automated results. This is available today. And it's another thing that if anybody's using, I would be really excited to talk to you about. I think this is the next generation of QC testing. We can do it better, we can do it faster, we can do it more often. And our QC will only get better because of it. One thing I want to talk about is our current process for moisture. You can put a moisture meter on your belt for your aggregates going to the asphalt plant, and it will give you moisture on the spot. I don't think a lot of people are currently using moisture meter analyzers, but I think it's something we really need to consider. Our current process is to have a technician get up at an ungodly hour in the morning, arrive at the asphalt plant before anybody else, go and grab aggregate samples from the stockpiles, and run moistures on them so that when the plant is ready to fire, we can make an aggregate correction. I find this to be ridiculous, quite honestly. And I know our technicians would appreciate that extra couple hours of sleep. So let's get more moisture analyzers on our belts. It's better. You will get what the actual moisture is rather than what it was 2 hours ago. I know where I live, you can have a rain event that lasts for a couple hours, and now that technician is running out and trying to get moistures again. We're constantly playing catch up with our moistures to do asphalt binder corrections. And we've already talked about asphalt binder content being a very important part of what we do. So let's do it better. Let's not be guessing what our moisture content is when the equipment's available to get it right. This is automated truck sampling, and this is something I am a huge proponent of. I've spoken to technicians in our industry, one in particular, who was around when our company first started truck sampling. And she talked about getting into the back of a truck with hot mix asphalt and coming out with blisters on her feet. Now, we have better processes today. We have better shoes. We put down rubber mats. But the reality is, we are still putting men and women in the back of a truck to collect a sample of mix that's about 300 degrees. There is a lot of opportunity for human error. You're dealing with the technician in the truck and the driver. And with all the safety protocols we put into place, we still have incidents where people get hurt in the back of a truck. Truck driver takes off because they didn't know they were there. It is an incredibly dangerous situation that we're putting our employees in. And the technology is here now for us to correct that situation. These are two examples of automated truck sampling. It takes additional training. Undoubtedly, there's room for error. But there is no reason to put our employees at risk when automation can deal with those situations. Taking it to the next level, this is something that's conceptual, and perhaps somebody's using it and I just don't know about it. But automated asphalt mix sampling at loadout. There is stream sampling being done in all kinds of industries. And while I realize we have unique challenges with temperature and asphalt binder sticks to everything, why wouldn't we consider taking a sample while the mix is already moving? Grab it before it gets in the truck, and then this material can be delivered to an ignition oven, to a gyratory. We can automate everything in our lab. So what I'm talking about now is fully automated QC testing. There isn't a single test that we currently do in our QC lab that can't be automated. There is nothing unique or special about getting a bulk, about running a gyratory, or about getting a binder content. It can all be done with robotics. So imagine that you're taking a swipe from the haul truck. You're splitting the sample out into its components, just like a human would do, but it's quite obvious to me that a robot could easily split out an aggregate sample. You're depositing part of the sample into an ignition oven or into an extraction system. You're delivering material to a gyratory. All of the testing that we do can be automated. And my vision for the future is a fully automated QC lab. It gives us better quality control. It takes away the human potential for error. It gives our customers more of what they're asking for, which is better quality control. As these type of things become more available, our customers start to demand them. And I think we're going to be a lot better off if we're setting the bar rather than them. So, done enough talking about QC. So I want to talk a little bit about some of the developments in the field. Once again, some of these are available, some of them are conceptual. Intelligent compaction. I had an opportunity this last summer to work with an automated rolling system and talk to the roller operators about how they currently do things. And especially when they're rolling in the dark, they're struggling. You know, where have I rolled? How far have I rolled? How many times have I hit that spot? And we equip them with pass mapping technology. And we got positive results across the board from every operator. New operators, people who've been operating rollers for 30 plus years that you wouldn't expect to want to change or think they knew how to do it better. None of them, or I should say all of them, wanted this technology on their pavers. They all wanted the opportunity to get their pass mapping exactly right. They all wanted to do the best job they can, and they all saw how this technology could help them do that. The other thing that's slowly becoming available, I'm not totally bought in that it's quite ready yet, is the ability to get automatic density feedback from our rollers. This could be a game changer. When we're talking about 3D paving and having more mix in some locations versus others, this would give the roller operator the opportunity to know what the density was and know if it needs an extra pass. So rather than setting up a rolling pattern that will work for some thicknesses and not others, this would just be automated density feedback. No more waiting for a nuclear gauge test result. No more waiting for a core that has to be run to the lab, dried back to get your density. You know what it is that day. As a contractor, the ability to know things immediately is huge. There are many times when we're running blind for 1 or 2 days because we can't get the data back. And we just keep running and crossing our fingers. It's not a good place for the contractor to be, and it's not a good place for the owner to be. If we can get information quicker, faster, it will make us better and faster. Taking it the next step again. Now that we have automated density, assuming we're going to get there, let's have autonomous rollers. If we have automated information about what our density is, and we have automated information about how many roller passes we have, we can make an autonomous roller. When you talk about GPS systems and making things scalable, it's key that we have a lot of other things in place, but this is pretty exciting. And we take this to the next level. We have autonomous pavers. We have autonomous haul trucks, all integrated, all knowing exactly where everything is, and the pavers can know exactly what speed they need to go because they know when the trucks are coming and when they're not. This could virtually eliminate stopping and restarting pavers. It could really create a lot of opportunities. Now, I'm convinced this is pretty far down the road, but I think it is what we need to be looking at. Doing completely autonomous paving, especially on our large projects on our interstates. Once again, all of this information that we're collecting is only going to help us be better. I ran across this driverless mining truck information just a few weeks ago, and the only reason I ran across it was in the news because they had an accident. So this is a mine in Australia. These driverless mining trucks have put on 15 million miles. They had an accident, and that's how they got in the news. Nobody was hurt. That's huge. 15 million miles. This is happening today. Driverless trucks are already a thing at this mine. They don't even think about it anymore. It's just what they do every day. I'm excited for the day when I can say that our industry is at this level. Our quarries and mines have driverless mining trucks that are eliminating human error and making the job site safer for people. Last thing I'm just going to touch on very briefly is drones. Drones are fun. They've been adapted pretty quickly. I even own a little one, although I can't really fly it. I pretend to. But these were an easy thing to adopt because people really liked them. You could get really good pictures. They were easy to promote. And they can really be used to make our 3D mapping and paving even better. We can use them to map our quarries, get the sizes of our plant stockpiles. And once we start doing that, we can continue to automate because we know what our supply is and our stock is at all times. So I'm not too worried about these getting adopted, but I do think they are a key component of all the pieces coming together. Now I want to talk about automation challenges and opportunities. So this is a sociological model that some of you may be familiar with. And one of the challenges with automation is adoption. We come up with an idea, we innovate it. Now who's going to use it? Who's going to be the first person to take it out of the box and try it? And those are innovators. And I want to be very careful. Innovators are not necessarily the people who innovated. They're not necessarily the ones who came up with the idea, but they're the first ones who are going to try it. And they're a very important component of making sure that our automation takes off and works. This group has a very high risk profile, but with that comes a lot of reward. Over the last few years, I've been working pretty hard on being a better manager. It's been one of my goals lately. And while I do that, I read a lot of books, I read a lot of articles. And one of the things I read was that to be a successful manager, you only have to rewrite 60% of the time. I didn't believe it. I talked to a lot of people about it. 60%? That's not even passing. How can you be successful if you're only at 60%? The more I thought about it and the more I looked into it, and the more I read about innovators, they are the most successful, the most profitable, and their companies do the best. And they only were right 60% of the time. It's just enough over 50 that it makes you better and faster, and it balances out the 40% that you got wrong. So if you're doing things right, 40% of the ideas, 40% of the things that you've tried are sitting in your lab, sitting at your company, not being used. We need to allow ourselves more room for error, more room to be wrong, because most of the time, we're gonna be right. I know quite a few people in this group, and I have all the confidence in the world that if we're making educated guesses about what technology to move forward, we will be right at least 60% of the time. But we have to give ourselves the leverage to not always be right. For me personally, that's hard. I'm more of an early adopter. I like to know that something works. I don't mind working through the glitches. I don't mind dealing with problems, but I don't always want to be an early adopter. And I would challenge each and every one of you to try to move up a level on this sociological model. So I was talking about being an early adopter. So the innovators try it. The early adopters are the ones who get stuck in the loop of work and rework and trying new things over and over again. But one of the great things about being an early adopter is you get to build it how you think it should be built. By the time it gets out of the early adoption phase, it's pretty much somebody's product. And it's the early adopters who make those decisions, who set up the software, who work through all the challenges and make it possible for it to become an actual product that's used. As I was going through challenges of adoption, I found this modified cycle, and it talks about the overhype that happens when a new product comes out. And if a product becomes overhyped, it can create a chasm between the early adopters and the early majority. What happens is the innovators talk so much about the product and tell everybody how great it's going to be that by the time the early adopters get it, they're just disappointed because it didn't hold up to the expectations that they were told. I really like to overhype things. I think it helps sell them. Dan will appreciate this. One of my key phrases over the last few years has been Lestrada for life. As I've been trying to get that software off the ground, I overhype stuff constantly. And I have disappointed customers on a regular basis. So I think this, and talking about myself again, and this being one of my challenges, I just want to make sure that when we're doing this, when we're talking about automation, that we make sure we're realistic about it, because we don't want to create this chasm, this delay in our automation. One example I feel like in this industry is warm mix asphalt. 10 years ago, everybody was talking about warm mix asphalt. It was going to be the next big thing. It's been used, but I don't think it's reached its full potential. I think we're in this chasm where we have the early adopters using it, but I don't feel like the early majority has yet. It was overhyped. We were told it would save us all kinds of money, and it just isn't delivering on the hype. So I think this is something that we can all work on to make sure that the products that we're talking about and the things we're trying to deliver have realistic expectations to them. Another automation challenge is training. When we automate, our employees will have changing roles. It's just a fact. There's nothing to be done about it. We have to work within that system. One of the more recent major shifts in industry where there were fewer jobs available, significantly fewer jobs available, more than we will see in this shift, is farming. In 1910, less than 20% of 14 to 17-year-olds were in high school. And our government at the time looked around and realized what was coming. They realized farming jobs were going to decline precipitously over the next century, and they invested heavily in secondary education. By 1940, just 30 years later, over 70% of 14 to 17-year-olds were in high school. And I can speak personally to this. My dad grew up on a farm in the 50s and 60s, and he tells stories about not going to school in the spring and the fall because he had to be home to help with chores. There were fields to plant in the spring, and there were fields to harvest in the fall, and the automation was not available where he could go to school. So he stayed home and helped on the farm and went to school in the winter. I grew up on that same farm in the 80s and 90s. I didn't miss a day of school. I wasn't needed. The automation was available at that time that everybody I went to school with at the time never thought about missing school. Automation fundamentally changed the agricultural industry, but because the government at the time put the money into the training, that generation was ready for the manufacturing industry, and they were prepared to take on the new jobs that were available. I don't know that our current political system will see what's coming for our industry, and I know we are struggling as it is already to find qualified workers. So this may be a challenge that we as an industry have to take on ourselves. We may have to train the next generation of employees for our industry. However it works out, we need to be cognizant of this, and we need to be prepared to get the training done however we need to. One thing I want to talk about with challenges is scalability. Irv brought this up when he talked about moving from county to county and the markers changing. We simply cannot accept technology that isn't scalable. It will hobble us. It will make us very ineffective. We must demand that the manufacturers of these automation products make the data transferable between instrumentation, so we're not building a bridge to nowhere. The key to automation being what it truly can be is that we can integrate all of our data and information, and we can't do that if every manufacturer wants their own black box of information. So we as an industry must demand that that is not the case, that we can get the data, we can send it where it needs to go, and that it will work with the technology of the future. I was working with equipment this last summer, and I was told when we got it that we would be able to have that information available in the lab from the field. Got it, and I was told it wouldn't work with the cell towers in that area. It's unacceptable. And I realize the technology is growing and getting better and faster, but we cannot let the manufacturers make black boxes. I think it will truly set us behind. Now I want to talk about some opportunities. One of the themes as I've been talking about all this is quality control. And I really believe automation will make us better and faster. We can really turn the dial up on our quality control by using automation. Our customers will always insist on the highest quality that the current technology can give. So let's deliver it to them in the best possible way. Another thing that I've talked about is safety. Safety is a value of the company I work for, and I hope it's a value in everybody's company. Getting home to our families at night is a value that I think we can all strive for. If we can get our equipment operators out of traffic, especially traffic that's reading text messages, answering their cell phones, becoming increasingly distracted, we can make them safer. If we can get them out of the back of hot mix asphalt trucks through automation, let's do it. Let's do everything we can to make sure all of our workers are safe and going home at night. Another opportunity, which has been a theme, I feel like, as I've talked, is integration of data. From the top to the bottom, from the day the aggregate is produced until it lands on the road, we'll know more than we probably ever wanted to know about our materials. And this can make us better. When I query people in my company about what one of their biggest challenges is, what takes up the most time in your day, what can we do to help you, I consistently get the answer, emails. Everybody is sick of the sheer volume of data and information that we're trying to transfer back and forth through emails. By integrating our data and making us autonomous processes, we can create ways to more efficiently deliver this data and information. And I think everybody can get on board with getting less emails. So in conclusion, remember to ask the right question. Rather than focusing on the solutions, figure out the question you're trying to answer. Find solutions that exist. Many times there are already solutions that are available. And last, be open to change. Consider moving yourself on that adoption scale up just one notch. I want to thank you for your time. I hope you found some of this informative, and I will take any questions that you have, maybe.
Hello, Stacy. Kevin Hall, University of Arkansas. First of all, wow, what a great job. You did a fabulous job, and it's a great presentation, a very important presentation, and I thank you for your comments on that. I do want to get your take on one plea that I would have in this quest for the next big toy, the next big thing, doing what we already know how to do. And I'll give you one example, maybe you want to comment. We talk a lot about automation possibly enrolling in density and things like that, and so we can do it better and faster and more precise, but yet we still only insist on 8% air voids in the as-built, when we know that every other percent that we go further, that pavement's going to last longer. So the automation's not going to help that. I think there's a balance there between innovation, but yet still doing what we know how to do. Do you want to comment on that?
I absolutely agree, Kevin. One of the things that automation can do, hopefully, is free up our technicians and our operators to focus more on those kind of tasks, getting from the 8% to the 5% to the 4%. I would really hope that as we automate, we're using the knowledge base that we have built in our industry to make better pavements.
Stacy, this is a great session. I remember, in the 1960s, and who am I? I'm Jeff Rowe with Avatec. But going back to those 1960s and 1970s, you'd watch things like Star Trek and the talking, video talking that they do, and now it's an everyday reality. And we never dreamed of think out of the box type scenarios. And, this is interesting. I'd like to go one step further on some of your thinking outside the box. Why do we even need labs? Okay? Why can't we design plants and equipment that can actually analyze and test our materials automatically on the fly? Okay? That's, if you think about the optical technology that we have for looking at gradations and understanding, film thicknesses and binder contents, maybe we don't have to take a sample and do a gradation and a binder content in a lab. It could all be done automatically through new technologies that we have yet to invent. The same with gyrated compaction and understanding the resistance of that material to flow. Maybe we can do that on the fly. What we have to do is we have to challenge our research institutions to have that vision of where we might be in 20, 30, 40 years' time. I think we can go a lot further with some of our ideas in asphalt paving technology, and it's a question of thinking outside the box.
Thank you, Jeff. I love it.
Nathan Moore, NCAT. Stacey, that was a very interesting presentation, just kind of giving an overview of all the different things we can automate. But I did have a question. Nathan Moore, NCAT, in case I didn't say that. So you have a good vision of where this industry will be and what we hope to be in the near future, but right now we're not there. And so specifically addressing like between lab repeatability on some of these tests, I'm thinking of a specific example in terms of like the fine aggregate specific gravity tests where manually shaking it versus putting it in some type of automated shaker, you get different results. So in the meantime, while you have early adopters versus late adopters, how would you, what are some of your comments about addressing the fact that whether you automated testing versus manual testing, you don't get the same results on a couple of these tests? I was wondering if you could comment on that.
That was something that we ran into when we were trying to get an ASTM test method for extraction recovery manual. One thing that I think we can do in the near term is looking at our ASTM and our ASTRO test methods and try to make them more adaptable to this change that we expect is coming. We shouldn't have to write a new method. And the fact that we're getting a different result makes me wonder if we're doing it right to begin with. And you talk about early adopters, late adopters. We have to bridge that gap somehow, whether it's with a correction factor or something. But I think there's ways through it, but you're absolutely right. That is going to be a challenge as we move forward.
Okay. Baoshan Huang from University of Tennessee. Excellent presentation, and actually gave a very good overview of the process of automation in this industry. And I just want to make a comment. And as we go through the age of more smartness and with the connected vehicle and other sensor technology, especially with satellite, Internet of Things, and I would like to see this actually coming to our industry, no matter we mention it or not. As you have already give example of intelligent packaging and the driverless compactor, etc. And maybe if we can somehow a little bit put emphasis on the 5Gs or the satellite, even 6Gs with the kind of like a communication with network and sensor technologies, and that will be how it will kind of like impact our paving operations, our quality control, and even in the pavement kind of like the maintenance and the management strategies and operation. For example, we may be able to kind of like have more like institute or kind of like a dynamic kind of like input of payment response, for example, have a bit more smartness. This is something I would like to see personally. And I think we are at the age that the industry should get into that era. And just my comment. Thank you very much. Excellent presentation.
Thank you.
Gail King, consultant. Stacy, I too compliment you. Just the challenge of thinking automation and new ideas is so important to see here and be reminded of. And there are also things, the laws of unintended consequences sometimes that you point out. Like, whoa, your question in particular about needing automatic samplers in our trucks kind of strikes a note because, you know, Peter Grass and Napa and NCAT did so much work to understand the asphalt fumes issue over the years, just a few years ago. And as part of that, we know the contractors stepped up to the plate with all of the voluntary equipment, along with the equipment suppliers, to take the fumes away from the workers. At the same time, we learn we're putting workers inside of trucks where the fume concentrations are probably the highest they could possibly be. So all the other safety considerations, we're also putting them in the worst possible environment for fumes exposure and all the problems that can create. So just adding to what I think you said, we need to change, and some things we need to understand all the consequences and improvements that can come from that change.
Thank you.
Irv Ducatz, Matthew Construction. To echo what Kevin said, wow, fantastic presentation. And what the point that I want to underline in your presentation is the key thing of automation is consistency. And one of the things that I was going to mention, and I see Greg behind me from the Minnesota DOT, was to brag on their implementation of intelligent compaction in Minnesota. And one of the things that we found is that improves consistency. And then to take that to the next level, one of the biggest issues facing the industry at all levels is consistency in testing. And that's one thing that automation gives us. And the concerns about what number is right, as you mentioned, it's changed over the years. And it's all based on what do you set as a benchmark. And I think with a standardized automated system, we can establish benchmarks. Everybody tests to the same standards. So again, compliment you on an excellent presentation.
Thank you. Those are some great ideas, Irv.
Tim Ashton-Brenner, Federal Highway Administration. Thank you very much for the presentation. I agree with others. It's very interesting. I was not aware of many of those things before, so very insightful. I know when you talk about automation, you mention a few caveats, things we need to keep in mind that go with automation. For example, safety, very important things. And I just have one comment or one suggestion to include on that list, and that would be the role of quality assurance. The quality assurance program is very important. You know, we know the contractor responsible for quality control is a very important role. Then also the agency's role for acceptance is also very critical. Unfortunately, even with the paper system we have, we're seeing numerous struggles with the agency acceptance program and making sure validity of data and so forth. So as we go to automation, I don't necessarily see that getting better. I don't see that as a solution. So when we talk about automation, I think there's roles for quality assurance. As we talk about the quality assurance program, there's roles for acceptance, and there's roles for quality control, and we just need to keep those very well defined.
That's a great point.
Thank you, Stacy, for your presentation on automation and kind of moving the industry forward. I grew up working on a dairy farm, and you know, I always thought when I came to the civil engineering world that things were a little slower to be adopted than what the agricultural, which seemed kind of backwards to me when growing up on a farm, which we were supposed to be the backwards hayseed people. But anyways, my question, I work for Minnesota DOT, and we've got IC, we've got thermal, we've got rolling density meter that we're working on. All this automation, which is great, putting more tools in the hands of our contractors to make a better product. I appreciate Irv being here, one of our contractors. I wish we had more of them. And my question really is, what about the contractors that are, because we have those that are resistant to technology, okay? They want us, you know, to keep things the way they are. Automation, costs money. If you're sort of on the leading edge, then they're like, well, you implemented it for a couple projects and then you said, no, it didn't work, and now we got a $20,000 piece of iron sitting in our lot. And the other thing is how do we move forward with technology without forgetting going back to the basics? We have every project on our state system, 4 lane miles or more, we've got IC going on it, and we've got thermal, and I'm still going out there as this assistant state bituminous engineer worrying about basically going back to the basics and workmanship. Those are really our big issues, and I can't even get, you know, them to turn the vibrator on the screed, for example, and things like that. I mean, it's simple things like that. So how do you implement technology without forgetting the basics?
I think one of the big things there would be that we have the knowledge. We know what we need to do. And if we automate it, we can automate it to be right. We can't force people to compact correctly. We can't force people to deliver material and load the truck correctly. If it's automated, we take out some of the human factor and we can program it to be exactly what we want it to be. And we have the knowledge to do that. So I agree, there's a lot of challenges, especially when you're talking about people who don't want to adopt new technology. And there are always going to be people who are not going to accept something until they are forced to. It's just part of like the sociological factors that I showed you. So I think, you know, we work through them as best we can, but at some point you just have to put the hammer down, literally the Marshall hammer, and move on.
Louay Mohammed, LSU and LTRC. Stacy, I want to join the others, and you got a lot of thank you, so it's a nice presentation. Your talk mainly, the theme is to improve basically pavement performance and durability. And lots of automation is on the component materials. And sometimes, you know, component materials may not necessarily lead us to that direction, other than to say that is what we are getting, is what was specified. So the next challenge is that, to me at least, would be automation, and you slightly mentioned on it, is sample compaction and sample fabrication, getting it ready prior to mechanical testing, and ultimately mechanical testing. I just completed a survey for NCHRP on sample preparation. It's extremely exhaustive. It's got a lot of information which tells that there's a lot of different variables. So I wanted to hear your thoughts on what do you think, where we might be in terms of getting to the point where we get into mechanical testing through automation and to meet the performance-based specification. Ultimately, that's where durable pavements and allow us to use many different other materials that otherwise may not fit the component specifications.
No, that's a great question. As we move toward balanced mix design, performance engineered mix designs, and those type of things, I would challenge anybody who's developing those tests to evaluate how they would automate them and be that part of their implementation. I don't have a good answer of how to get there, but that would be my challenge to people doing it, is that that just becomes part of the thought process, that at some point the industry will not accept a test that can't be automated.
Audrey Copeland, National Asphalt Pavement Association, and these are more comments, so 3 comments. I wanted to address what Baoshan said earlier about incorporating intelligence, being smart. That's something that we've started exploring at Napa. In terms of positioning asphalt pavements, you know, as the smart pavement, as the intelligent choice, and this goes along with the focus on smart cities, the Internet of Things, connectivity, sensors. You mentioned big data. And really what it boils down to is being able to turn all that information into project intelligence and being able to make educated choices. So my point is, this is where I see AAPT being very helpful to the industry in terms of helping us to continue positioning asphalt pavements as the smart choice. I firmly believe that we are well positioned. The things that are going to be important in the future as we move to automated vehicles and driverless trucks are that the pavement is in smooth, good condition, which asphalt pavements can readily provide. And I think they're also very accommodating to the sensors and being able to accommodate getting that information from the pavements. Second comment is you mentioned the workforce. And I do think that automating our industry is going to help with our recruitment efforts. So just to let this organization know, Napa has established a workforce development committee for the asphalt pavement industry where we're looking into how to recruit and retain workers. So we're always happy to have input and help on that. And then finally, you mentioned the farming industry, and that's actually one industry that we're tapping into for this workforce, because a lot of what they value in the farming industry in terms of how they educate their workers is the same things we value in terms of quality, mechanical abilities, things like that. So we actually have a partnership with the Future Farmers of America where we're starting to really introduce our industry to the high schoolers that participate in Future Farmers of America. And again, I want to echo, you did a very good job. I can tell that you put a lot of thought into this presentation, so I really appreciate it. Thank you.
Thank you, Audrey.
Well, this is Baoshan Huang again, and just want to thank you, Audrey, for echo my comment, as well as Stacy for your excellent presentation. And also, I think you're from Tennessee, right? Thank you.
Thank you, Stacy. As we approach the lunch hour, I want to recognize that this was NAR's and Stacy's first presentations at AAPT. I want to encourage both of you to do more. Also want to thank the board, especially Randy and Adam, for their input on this. Stacy Glidden, of course, Pascal Macarenas, Brett Williams, Todd Lynn, Brian Prowl, Mike Huner, Robert Lee, and Stacy Diefendorfer. Got to get my 2 Stacys figured out. I really appreciate the passion on both of the topics, and what I want to leave you with just a few housekeeping things and then a last comment. Gotten some questions about the presentations and PowerPoints, and those are going to be on the website. You'll have to log in. Eileen said that she is working on getting everybody who's registered fixed up so you can go in and view those. Give us to after lunch, and you'll start seeing some of that light up. Also, for the moderators, be sure and get your, if you have any questions on your PowerPoint, you need to verify that those are locked in back there with the AV. And the other question that we had was, remember, as any good AAPT meeting, as you go to the microphone, always mention your name and the company you're with. With that, I'm going to leave you with this thought. I have a good friend in a technology world. I like to hang around techies, and they make me feel less nerdy, as my wife tries to remind me of that often. And the bow tie doesn't do much to help with that. But my friend went to work for Apple, and he shared this letter with me back in January, and I think this fits with the session. So fit this in with your company. I'm going to read it as it came to him from Apple. And it was on his first day of work. There is work, and there's your life's work. Life's work is the kind of work that has your fingerprints all over it, and the kind of work you'll never compromise on. That kind of sacrifice that you would sacrifice a weekend for. You can do that work at Apple. People don't come here to play it safe. They come here to swim in the deep end. They want their work to add up to something big and something that can happen anywhere else. And they sign their name on that. So with that, I would like to end this session and thank you for taking some time on the Leading Edge Forum, and enjoy your lunch.